Introduction to Differential Equations. So differential equations involve both variables and derivatives. And let's have a look at an example of a differential equation. So a nice simple one. So that dy dx equals y. This is an example of a first order differential equation because it involves a first derivative. So we can see the first derivative being dy dx. And here, whatever's on top here, we're going to treat as our dependent variable, and whatever's on the bottom is going to be our independent variable. Let's have a look at an example of a second order differential equation. So this might be d2y dx squared plus dy dx plus y equals 0. So this is a second order differential equation because it involves a second derivative. So a third order differential equation might look like d3y dx to the 3 minus 3 times d2y dx squared plus 2 times dy dx equals y cos x. So this is a third order differential equation. Now solving a differential equation looks at getting an expression for our dependent variable. So in all of these, the dependent variable is y, because it's on top here of our derivative. And we need an equation that defines what y is. And let's have a look at a nice simple one to start with. So let's have a look at the equation dy dx equals x. So we're trying to solve this differential equation in terms of our dependent variable, which is y. And one way we can think about this is if we take both sides and multiply by dx, these dx's will cancel out and we get dy equals x dx. And now we can integrate both sides. And the integral of 1 dy is just y. We can add a constant here, so let's just call it c1. And the integral of x dx is just x squared on 2 plus another constant with this integral, minusing the constants from both sides, or let's minus c1 from both sides. We're going to get x squared over 2 plus c2 minus c1. And we can just tidy this up a bit, saying y equals x squared on 2. Now, a constant minus a constant is just another arbitrary constant, so let's call it c. So whenever we're integrating both sides of a differential equation, we only have to add a constant to one side, because adding a constant to both sides and then bringing them together just gives us another constant. So this will just save you a bit of time in the future. So just add a constant to one side. And this is the general solution to this differential equation. And this value of c will just depend on some starting conditions if it's a real world example. And you always know if you have a solution, if your solution's correct, if you just differentiate it. So if we differentiated this, differentiating y just gives us, with respect to x, gives us dy dx. And differentiating x squared on 2, we can bring the 2 to the front, minus 1 from the power, and the differential of a constant is 0. The 2's cancel out, and we get dy dx equaling x, which was our original differential equation. So we know that this equation satisfies the differential equation. And just graphically, if you wanted to look at what this is representing, our solution of x squared on 2 plus a constant is all the possible parabolas that will satisfy our condition. So this is y equals x squared on 2 plus 0. This would be y equals x squared on 2 plus a constant. This would be another one with a bigger constant. This would be one with a negative constant. And all these equations satisfy the initial differential equation.